Good morning. This is your stats sensei, Mr. Spensei, and I'm going to break this assignment down into two videos because it's pretty long. So let's get started. So if the probability of A equals 0.1, the probability of B is 0.6, and the probability of B given A equals 0.5, then the probability in A and B equals what? First off, if they're asking for the probability of A and B, they're asking for the probability of A intersect B, but they've told us this. So with that, we're going to go ahead and write our formula, and that's the probability of B given A equals the probability of A and B over the probability of A. Well, the good news is that is what we were looking for. So we're going to start plugging in. Probability of B given A is 0.5. So 0.5 equals the probability of A and B over, and they told us the probability of A is 0.1. At this point, if I multiply both sides by 0.1, this goes away, and I end up getting my answer of 0.05. One of people's biggest concerns is they wanted to multiply the probability of A times the probability of B and equal the probability of A and B. That's only true if they're independent, all right? Because my students wanted to go 0.1 times 0.6, and that would equal 0.06, but we can only do that if they're independent. They didn't tell us that. So we have to go use the conditional probability. The conditional probability is always true, regardless whether they're independent or not. So because they didn't tell us they're independent, we can't use the general multiplication. All right, rolling on to the next one. One of the most effective recruiting techniques to the Virginia Tech Honors Program is getting the students to visit campus before making a decision. According to recent data, 45% of the potential honor students visit the campus before making their decision. If the student visits, they accept the offer to attend Virginia Tech 95% of the time. The students that do not visit the campus before making a decision will attend 55% of the time. Knowing a student will enter the Virginia Tech Honors Program, what is the probability that they visited the campus before making their decision? All right. So first off, I read this and I go, hey, I have three numbers and I have two variables. And because I have three numbers and two variables, this is likely to be a table. So let's start organizing it. Because even if you're wrong, the table is still a great way to start organizing data, and organizing it makes a big difference. So it says, according to recent data, 45% of the potential honor students visit the campus. Okay, and I also know that in this case, my two variables are visit and attendance. Well, this is only predicated on visit. So this looks like my one variable, and it happens to be on visit. If the student visits, as soon as you see the word if, that means given, all right? So this if is another key word for given. So this is a condition right there as soon as they said given. As soon as they've conditioned it, we know it's on two variables. Given the student visit, probability they accept is 95% of the time. Well, guess what? That right there is going to be two variables. But the students that do not visit, all right, do not visit, make their decision to attend 55% of the time, once again, visit and attendance. So this is also on two variables. So we have our 45% is 1, so we know this is going to be 0.45. The complement of 0.45 is 0.55, 1 minus that. And of course, this number is always 1 whole. So I'm going to go ahead and write those down small and bring them up. And this was visit, no visit, attend, does not attend. All right. So let's look at the first. If the student visits so we're looking here in the visit column. The offer they will attend 95% of the time. So this is going to be 0.95. And this is 1 minus 0.95. The next one, the students that do not visit will attend 55% of the time. Well, guess what? So we get another 55 written right here. And this will be 1 minus 0.55. So when I go ahead and multiply all that out, and hopefully I've done this correctly ahead of time. Hopefully this is 0.4275. Hopefully this is 0.0225. 0.3025 and 0.2475. These sum across to be 0.73. These sum across to be 0.27. All right. Well, what was our question? What's the probability knowing a student will enter the Virginia college? All right. Remember, it's always intersection over given. In our intersection, well, first off, our given here is they're going to attend. So this is going to be 0.73. And the next question is, what's the probability they visited? Well, there's my intersection of 0.4275. And so that would be our answer to the first one. All right, moving on. If the probability of A equals 0.55, the probability is P equals 0.42, and the probability of A and B equals 0.4, then a probability of A union B equals. Well, this is just asking for the general addition rule, which is the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Well, they've already given me B. A is 0.55. Probability of B is 0.42 minus the intersection, which is 0.40. All right. So when I do my math, I end up getting the probability of A union B equals 0.57. I'm going to talk about the intersection real quickly here, just to make sure that we're completely clear. Notice the intersection is 0.40. If this value is anything but zero, if that value is anything but zero, it's not mutually exclusive. So we know for a fact that this is not mutually exclusive. Now, if they're independent, 0.55 times 0.42 would equal 0.40. But when I take my calculator out, 0.55 times 0.42, I find out that it's not equal to 0.40. So my intersection is not, this tells me A and B are not mutually exclusive and they're not independent. They're neither. All right. You don't have to be both. You don't have to be either one. You could be neither. You can be mutually exclusive, or you can be independent, or you can be neither. And this one happened to be neither. All right. So that will take care of that problem. I'll write this right in front. At a particular fictional high school, 100% of the students go to college, 45% of the students take 4 years of mathematics. All right. This is predicated on math. It looks like it's predicated on one variable. Of those students, this is telling me from the group, so this right there tells me this next thing is going to be conditional. Of those students who take math, 70% graduate from college in 4 years or less. So of those students, from the students that take math, so this is going to be two variables. The students not taking 4 years of math will graduate from college in 4 years or less only 40% of the time. So not taking 4 years of math. So we're talking about math here and in 4 years or less. So consequently, this is also two variables. So the one that we want to start with is this 0.45, and be careful because a lot of times they'll try to confuse you by putting it in words. Hide the number in a word. All right. So this is 1.0. We're going to go ahead and bring these up. And for math, not for math, graduate less than 4, graduate greater than 4. All right. So I have some labels there. So of those students, 70% graduate from college in 4 years or less. All right. So that would be right here, 0.70. This is going to be 1 minus the 0.70. So this is going to be 0.30. I don't have room to write 1 minus, but it's 1 minus that. And then it goes, the students not taking 4 years of math. So we're looking over here, not taking, will graduate from college in 4 years and less only 40% of the time. So this is 0.40. And this is 1 minus 0.40, which is just plain old 0.60. Once again, I didn't have room in my square to show my subtraction. Then I multiply this together and I get 0.315. I multiply these two together, I get 0.135. And these two sum together to equal this. This times this is 0.22. This times this is 0.33. And we end up with these values. All right. What's the probability that a randomly selected student from the high school will graduate in 4 years or less? Well, that means I'm just looking for this marginal probability right here, which in this case is 0.535. So we want the probability that they will graduate in less than 4 years, and that equals 0.535. All right, so that's our answer to that one. Moving on to number 5. Hypothetical records indicate that the probability of freshmen in high school has a maturity issues or family issues is 0.71. This is a key phrase. Anytime you see or, better think about adding. And when you think about adding, you better think about the general addition rule. But we're sitting there circling and go 0.71. The probability that a freshman has maturity issues is 0.48. We also know that the chance of a student having family issues is 0.34. What is the probability that a freshman has both maturity and family? All right. Well, the fact of the matter is I could probably set this up as a table, but anytime they give me or, I'm like, you know what? Might be able to do this with the general addition rule because it tells me I'm adding. Remember, the general addition rule is a probability of A union B, but in this case, we have family. So probability of family union maturity equals the probability of family plus the probability of maturity minus the probability of family intersect maturity. All right. Well, they tell me the probability that they have the or both, which is 0.71. Once again, or tell me I'm adding. Probability freshman has maturity issues is 0.48. Okay, so there's my 0.48. The chances of having family issues is 0.34. And we're looking for both. All right, so when I add this up, I get 0.71 equals 0.82 minus the probability of family intersect maturity. I subtract both sides from 0.82 from both sides. When I do that, I end up getting negative 0.11 equals negative probability of family intersect maturity. Basically, I can multiply both sides by -1, and I get the probability of family and maturity, or both, equal to 0.11. Please know, and is another word for both. So this is not only my overlap, this is my intersection, and this represents both, and it represents the word and. Okay? All right, moving on to the next problem. According to the American Pet Manufacturers Association, 39% of households own at least one dog and 34% of US households own at least one cat. All right, so I'm going to call this my dog. This is my cat. And 34% of the US households own at least one cat. Assume 60% own a cat or a dog. All right, once again, there's that word or. And because it has the word or, probably looking at the general addition rule. So it asked me to draw a Venn diagram. To do that, I need to find the overlap. They didn't tell me they're independent, so I can't just multiply them. So I'm using my general addition rule, and I go the probability of cat union dog equals the probability of cat plus the probability of dog minus the probability of cat dog. All right. 39% own at least one dog and 34% own a cat. Assume 60% own a cat or dog. So my cat or dog is this right here, because union, that's my union symbol. So that's union. That's the word or. And that means add. All right. So equals 0.34 for the cat plus 0.39 for the dog minus the probability of cat and dog. All right. So we have cat dog written right there. When we add that up, we end up getting 0.73. So 0.60 equals 0.73 minus the probability of cat dog. All right, subtract 0.73 to both sides, and I get negative 0.13 equals the probability of a negative probability of cat dog. Multiply both sides by -1, and end up getting 0.13 equals a probability of cat dog. Remember, we'll never have a negative probability. If you do, you made a mistake. So go back and check your work. A lot of times you just needed to multiply both sides by -1, but never have a negative probability. All right, so the probability of a dog was 39%. So, but I've already have 13% here. So this is going to be 0.39 minus 0.13. But when I do that, I end up getting the probability of 0.26. This 0.26 means this is the probability of having a dog but not having a cat. So this is the probability of only having a dog. All right, for cat, it's going to be 0.34 minus 0.13. So the probability of only having a cat is 0.21. All right, so this is the probability of having one. This is the probability of having a dog only, a cat only. This is the probability of having both. All right, well, the one thing I'm missing is the outside part. Well, they told me this was 60%. 60% is the general addition rule. That's the addition of this plus this plus this. So that means 1 minus that is 0.40. 40% have neither. And we're going to see that in the next part. What's the probability randomly selected household owns neither a cat nor dog? So that's 1 minus the probability of cat dog. or not cat dog, of cat union dog, which is 1 minus 0.60. That equals 0.40. Now I know that that bothers some people, so we can look at it this way as well. 1 minus 0.26 plus 0.13 plus 0.21. And if I do that, I end up getting 1 minus 0.60, which equals 0.40. Either method would be sufficient. All right. So the next thing is, what is the probability that a randomly selected U.S. household owns both? So here's the word that we're looking for. Both. Both means the intersection. They're looking for the overlap. Well, I can just look here and go, all right, they're looking for cat dog because they're looking for both. Probability of cat and dog equals 0.13. I've already shown my work. I don't need to go back and redo it. I did the work up here. Okay, so there's my work. As long as I state my answer, probability of the intersection equals 0.13, we're good to go. What's the probability that a randomly selected U.S. household, given they have a dog? All right. So remember, it's always intersection over given, which is the same as saying the overlap over the given. And in this case, we were given that we had a dog. Well, the probability of a dog was, so we're looking for the probability of dog. And we're looking for that intersection, or dog intersect cat. Dog intersect cat is that overlap, which is 0.13. And the probability of a dog, please don't forget, was 39%. It's the whole circle here. It's the whole circle, so that's a 0.39. All right. And by the way, for your test, please write your fractions and then give your decimals. Please do that. Okay. All right. Next question. In a certain school, 17% of students are enrolled in a psychology course. 28% are enrolled in a foreign language. And 32% are enrolled in either a psychology course or a foreign language or both. It was nice that they put the or both, but they really didn't have to. But what they're really saying here is they say the word or, so they're telling me to use my general addition rule, which I've written here. Probability of A union B plus B, probability of A plus B minus the intersection. Remember, or tells me that general addition rule. So they said they're in A, or they're in B, or they're in both. And remember, this symbol right here is my both. So I'm going to go ahead and write this looking like it's psychology. So the probability of psychology union the foreign language equals the probability of psychology plus the probability of foreign language minus the probability of psych and foreign language. All right. Well, what was it? 32% are enrolled in either or both. So this is my or. That was my key phrase that told me that that went there. Then we have 17% are enrolled in psychology, plus 32% are in foreign language, minus the probability of psychology and foreign language. So 0.32 equals, did I write something down wrong? And 32% are here. So this is equal to 0.49. Apparently I have this wrong on my key, it looks like. I subtract 0.49 from both sides, and I end up getting 0.17, a negative. I subtract it from both sides. So negative 0.17 equals negative probability of psych and foreign language, multiply both sides by 0.17, and multiply both sides by -1, excuse me, and I end up getting the probability of psych and foreign language equals 0.17. Somehow or another, there's a math issue of some sort. What did I do wrong? Excuse me. I did that completely wrong. I need to go back and reread. Sorry about that. So probability of psych union foreign language equals the probability of psych plus the probability of foreign language equals the probability of minus the probability of psych and foreign language. So 17% are enrolled in psychology, 0.17, and 28% are enrolled in a foreign language. And 32% are enrolled in both. I mean, either, this is not just both, in or. All right, please remember that's a symbol for or. This is a symbol for both. So 0.132, excuse me, 0.32 equals, if I add these up, I get 0.45 minus the probability of psych and foreign language. Subtract, I get 0.13, a negative 0.13 equals a negative probability of psych and foreign language. So 0.13 equals a probability of psych and foreign language. And that's my answer. And I apologize for messing you all up on that. Once again, the or tells me it's union, so I use my general addition rule. Probability psych, probability foreign language minus the probability of the overlap or both. 0.32 equals 0.17. That's the probability of the or, which they gave me right here. Psychology or a foreign language or both, that means everything. And then 0.17 is psychology, 0.28 is foreign language, and this is the intersection. Here's what's going on if we're looking at a Venn diagram. We solved this and we got a 0.13 for both. Psychology. So this has to add up to 0.17. So 0.17 minus the 0.13 means 4% are in psychology only. This is foreign language. 0.28 minus 0.13. So 0.15 are in foreign language only. And turns out that 68% are in neither. And if I take 1 minus 0.32, that will give me the value. Or if I add up these values, these will also add up to 3.32. 0.04 and 0.13, 17%, plus 15 is 32. So 1 minus 0.32 is 0.68. So these are in neither psychology nor are they in foreign language. Again, I apologize for making an error on that one. All right. Having ham or turkey for Thanksgiving are independent events. Oh, that's important. The probability the family will have a turkey for Thanksgiving is 70%. The probability the family will have both ham and turkey is 17.5. That's important because that tells me this is the intersection. All right. Find the probability the family will have either a ham or a turkey. So here's what they're looking for. They said or. All right, so they're telling me that they want me to add, so they want me to use the general addition rule. So the probability of ham union turkey equals the probability of ham plus the probability of turkey minus the probability of ham and turkey. So I'm going to start plugging into this. And the probability family will have a turkey for Thanksgiving is 0.7%. Okay, great. So 0.70. And the probability that they'll have both a ham and turkey is 17.5%. Problem here is I don't have ham and I don't have this, so I'm missing two things. So I need to figure out how I can find the two things. But they gave me a hint. They told me they were independent. That means the probability of ham and turkey equals the probability of ham times the probability of turkey. We know that the probability of having a ham is 0.175. I mean, probability of having both is 0.715. We know the probability of a turkey is 0.70. So ham times 0.70 is 0.175. So if I divide both sides by 0.7, 0.7, where'd my calculator go? So 0.175 divided by 0.7 is 0.25. So that means the probability of a ham equals 0.25. Now that I have that information, I can plug this in. And when I do that, I end up having 0.25 plus 0.70 minus the intersection of 0.175 equals 0.775. All right. So in this particular case, we find that the probability of having a ham or a turkey for Thanksgiving is 0.775. Right. Hope that helps, and I will see you on the next one, and we'll cover some more table work. Talk to you later.